All right, guys, today we're going to learn about the distance and midpoint formulas. Now, when we deal with the distance formula, we're talking about distance between 2 points on a coordinate plane. So, like, for example, here, the distance d between points x1, y1, and x2, y2, just meaning the first point and the second point. And there's a formula for that. Tomorrow I'm going to get into you guys where this formula comes from. But your formula basically is you find the distance by taking the square root of, you find the distance or difference between the x values. So you do like the second x minus the first x and square that. And then you find the difference between the y values, so like you would do y2 minus y1 and square that. Then you're going to take the sum of them and then finish off by taking the square root. So you find the distance between the difference between the x values, the difference between the y values, square them, take their sum, then take the square root. So, for example, in number 1, if you have the point 3, -1 and the point 4, 0, all right, you would, to find the distance if you don't have the coordinate plane, you're going to use that distance formula. Now, I would recommend that you guys, for each problem, eventually when you work on these, is write down your formula. It is a formula you're going to have to memorize. So you're going to difference of the x values squared plus the difference of the y values squared, and then you take the square root. So we're going to do the square root of, well, I'm going to do, for my x values, I'm doing 4 minus 3 squared, because you get your x values from your points, plus y values would be 0 minus a -1 squared. So this would be the square root of 4 minus 3 is, so it's 1 squared, plus, this would be plus a +1, so it would be 1 squared. All right, which is basically the square root of 1 plus 1, or 2. Now, on the test at the end of the chapter, I'm going to let you guys leave it like that. If you're applying it to a real-life problem, you might take a calculator and actually plug in the square root of 2, which is approximately 1 41/100. All right, let's look at how we can apply or use this formula. If you look here, it says are -2, 3, -1, 1, and 2, 3 vertices of a right triangle. Well, if we want to find out if something's a right triangle, we use the Pythagorean theorem and check our lengths of our sides in the Pythagorean theorem. If the two smaller sides squared and the sum of them equal the longest side squared, then you know it works in Pythagorean theorem, and then it's a right triangle. So right now, though, we don't know enough information, but we can figure it out. We got to find the distance between all of these points. So we're going to use that distance formula in all 3 of these. We have 3 distances to do. So, like, there's going to be a distance between these first 2 points. I'm going to call that distance 1. So for distance 1, I'm going to do the square root of. My x's, I could do -1 minus a -2. And you might see it off that that's going to be plus a +2. So if you wanted to switch that right off, you could. And realize you could actually ultimately do either order. I could do -1 minus a -2, or do -2 minus a -1. Either way, if you notice, you're going to get basically 1 squared. So it really doesn't matter the order, as long as you make sure you do x's minus x's and y's minus y's. So like here, I could do 1 minus 3 squared. And when I do that, I'm going to get the square root of 1 squared plus a -2 squared, or the square root of, 1 plus 4, or the square root of 5. Now I'm going to leave it just the square root of 5 for now. Now let's see. We've got to do another distance. I'm going to do the distance between these 2 points and call that distance 2. So for distance 2, okay, again I want to subtract my x's, so that would be 2 minus a negative 1 squared, or plus a positive, plus, and my y's would be 3 minus 1 squared. So that gives me the square root of 3 squared plus 2 squared, or the square root of 9 plus 4, which is the square root of 13. So I've done the first 2 points together, the last 2 points together. I still haven't done these outer two. So that's going to be our distance 3 right here between those two. So for distance 3, I'm going to do, for my x's, 2 minus a negative 2 squared plus 3 minus 3 squared. So that would give me the square root of 4 squared, because this would be plus a positive, plus 0 squared. It's okay that that's 0. It's basically going to give me the square root of 16, or just 4. Now, all right, we didn't just need to, though, find those distances. We actually had to figure out whether these were vertices of a right triangle. So what we want to do is we want to basically see, does this work in our Pythagorean theorem? A squared plus b squared equals c squared. We got to be careful here. We got to make sure we put the longest side in the c position. So looking at what square root of 5, square root of 13, square root of 16, square root of 16 is going to be the longest. So it is the square root of 5 squared plus the square root of 13 squared, does that equal 4 squared? Well, root 5 squared is just 5. Root 13 squared is 13. Does that equal 4 squared, which is 16? Well, no, that doesn't equal. So since those aren't equal, we'd say no, this is not a right triangle. If it did work in the Pythagorean theorem, then we know, yes, it is a right triangle. Okay, so that's working with the distance formula. What we'll do is we'll work some with that more in class tomorrow, and I'll also give you an explanation of where that formula comes from. But let's talk about midpoint. Midpoint's pretty straightforward. It's not bad at all. All right, the midpoint of a line segment is the point on a segment that is equidistant from its endpoints. Now, when you're talking about that on a coordinate plane, the distance between 2 points, and the 2 points I'm referring to here is on a coordinate plane. The distance between the 2 points is the midpoint of the line segment connecting them. So let's look at the little investigation here and see what happens. Here we plot the point 6, 6. We go right 6 and then up 6. So that'd be right about there. So that's the point 6, 6. And you plot the point 0, 2. You don't go either way, left or right. You go up 2. There'll be right about there. So there's the point 0, 2. We want to find the midpoint of the line that would connect those 2 points. And I think it's pretty easy, straightforward to see that the midpoint's going to be right there, which is at the point 3, 4. Now, hopefully you kind of see something, and we can see that right in the graph, but you're not always going to have a graph. But if you notice, if you look, the x value here in one point is 0. The x value over here is 6. 3 is perfectly in between those 2 points. And if you look, y value here is 2. Y value in the other point is 6. All right? 4 is in the middle of those two, or the average. Each of these are the average or the mean of those two. So let's go to the other page and actually do a quick problem. It's really pretty straightforward. So let's go to the next page. Okay, the midpoint formula is basically when you find the midpoint of 2 points, 1 point and a second point, so x1, y1, and x2, y2, you're basically finding the average of the x values and the average of the y values. So you're adding them together and dividing by 2. So if we want to find the midpoint between 5, negative 1, and 3, negative 3, 7, we're going to take the, oops, sorry guys. We're going to take the x values, all right, 5 and negative 3. We're going to add them together and divide by 2 to find the x value of our midpoint. So, and then for the y value, we're going to average the y values in our two original points. So -1 plus 7 and divide by 2. So we basically end up with 2 divided by 2 and 6 divided by 2, which gives us a midpoint of 1, 3. Okay, so there's the midpoint of those 2 points. And all you had to do was use this formula here. Basically, you're finding the mean or average. Okay, so I think that's pretty straightforward for you guys. Now, if you want to look on the pages in your textbook at some real life examples, we'll probably discuss these tomorrow a little bit in class as well. There's an example of a real life example of how you could apply distance formula on page 746. And then on page 747, there's a real life example of a midpoint formula application. Okay, so we'll talk about this some more tomorrow and do some work with this tomorrow.